Hey guys, welcome to this video. So in this video, I'll be talking about the security layers of blockchain. So the first layer is SHA, that's Secure Hashing Algorithm, right? Now, secure hashing algorithm is one of the fundamental security aspects of blockchain, which makes it resilient and powerful, and it also presents opportunities to be able to implement blockchain on different use cases. Think of different use cases related to fraud, counterfeit, fake registrations, fake documents, fake passport documents, things like that. Secure hashing algorithm is one of the primary sources of security, which allows you to be able to leverage blockchain and implement it on a specific project for a certain use case to be able to limit or decrease the possibility of fraud or in different counterfeit issues that you may face in any business problem, right? If you think of global business problems in finance, companies who falsify financial records to be able to gain target revenues, right? Companies who are auditing companies who work with their clients to be able to misrepresent financial information, and then a year later they get caught by the financial regulation authorities. All of these are different use cases which specifically blockchain can be used to be applied here to be able to prevent and limit those cases from happening. Now, here's one thing we have to understand. We cannot eliminate fraud from happening, right? There's always going to be people who will be able to, or who think they can beat the system. But we can make it more difficult for these bad actors to commit any kind of fraud. And if we make it easily accessible, that means they're easily exposed. If any of those bad actors commit any of those fraud cases, they're going to be easily exposed. And that is what blockchain presents. How that works, secure hashing algorithm is one of the fundamental security layers that makes this possible for blockchain. You have other layers such as cryptography, asymmetric cryptography, and mining. All are these different security layers which can be, when combined together, present a valuable opportunity for us to be able to consider blockchain for these specific use cases, which can be applied across different sectors such as manufacturing, supply chain, logistics, financial services, and trade, and education sector, right? So we're going to see in this video how the security layers, SHA, secure hashing algorithm, plays a fundamental role in how it works from a security standpoint and how it can be applied for these specific different use cases, right? So I invite you to join me on this video to be able to understand and leverage how blockchain can help you improve your products and services, or to help you launch brand new services for your end customers. Thank you. Hey guys, welcome back. Okay, so in the previous video, or in the previous lesson, we covered blockchain today, what's happening in terms of the blockchain space. We covered what is JP Morgan doing in the blockchain, such as their digital transformation strategy, which they implemented for about $10 billion, and they allocate about $5 billion only for blockchain use cases alone. And we also covered some of the basic use cases of some financial institutions of how they leverage blockchain for their existing products and services to help them improve their value proposition in the market. Right? So now in this lesson, I'm going to be talking about some of the most fundamental aspects of blockchain, which is called hash functions, or the hashing algorithm which blockchain uses. And hashing is one of the security layers that blockchain uses in order for it to carry out its most fundamental aspect. Right? Let's take a look at how hashing works. Now, just keep in mind, hashing in blockchain is using the what is called the SHA, secure hashing algorithm of 256-bit, right? It is a way to cipher the messages within the blockchain system. Let's take a closer look as to how this works. Right, so this link is taken from a book called Blockchain Basic, I forgot what it's called here, I can show you. Blockchain Basics. It's a book by Daniel Drescher, and it has a very unique explanation about how blockchain works. It's a non-technical book. It actually does have some technical explanations, but essentially it puts things into perspective of how blockchain works for a for business owners or for business professionals who just want to have or generate or understand the basic foundations of blockchain. So this is an example about how hashing works. Now, hashing is a mathematical function, an algorithm, which means that for any input message that you enter into the hash function, you get a fixed length output of that specific algorithm function, right? Again, for every input message that you enter into the algorithm, you get a fixed length output message, right? That's basically coded or ciphered. Let's take an example of how this works. So let's say I put here, for example, Mike, and I get a hash value. Now, these are different hashing types. MD5 is a different hash type, the output, and SHA1. And there's SHA256, and then you have SHA512, which stands for Secure Hashing Algorithm. SHA256 is what Bitcoin uses, as well as all the major cryptocurrencies. Ethereum, Litecoin, and others, the majority of them, all use 256 in their blockchain network. So, what this means is the following. I'm just going to copy the output message here just to illustrate how this works and why this is such an important fundamental aspect of blockchain. Right? So when I placed Mike, I got the following, right, message, the output message. Okay? Now, what this means is, now mathematically, a hashing algorithm is a one-way operation. The input message I place here will always give me this fixed length output, which is this. Now, what that means is the algorithm formula will calculate the hashing output of that input message. Now, I cannot, mathematically, it is almost impossible for me to reverse it. I cannot do an output message from here and to generate the input message, right? Mathematically, it's not possible. There's no application or formula for me to be able to generate what was the input message for this specific output message, right? It's mathematically impossible. It is a one-way arithmetic operational message or communication or hashing function. What it does is it takes the input message and hashes it, and it ciphers the code and generates a fixed output length. Now, this number of characters here, it's fixed, right? Number of characters here are fixed. It will not be more. Even if I put I will still get the same fixed number of length messages, but it will not be the same, right? So if I put, like, for example, Mike walks, I calculate, and here's what I get. I get this, which is different than the previous output message, right? 9DC, FAE, and whatever, but it's the same number of length of characters, right? Now, this is critical and very important because hashing is one of the core fundamental security layers in blockchain, because inside the transactions in a blockchain block, hashing happens multiple times. The transaction gets hashed, and there's different layers of hashing that happens inside the specific block. This is a security function, because if I cannot reverse this, I will not be able to find out what the input message was, which means that for hackers and malicious actors and bad actors who want to be able to commit fraud or hacking activities on the chain, they will not be able to do so, because mathematically it's almost impossible to reverse this message into finding out what is the message here. Now, let's take another example. Even if I put a exclamation mark, calculate, and I get again a fixed length message output, but it is different from what I get previously. And now keep in mind, this is also case sensitive, right? So if I put, so Mike will always get me the same output message, right? Which is the first one that we got here, 9DC415, the last four digits, 63F7, 63F7. So go ahead and open this link and go ahead and play with it. Enter your name, enter your friends' names, enter different like gibberish entry points. I can also put a dot. A dot will give me a fixed length output. Now, why is that important? It's important because it eliminates the possibility of any bad actors to be able to figure out what is the input message, right? Again, it's a security option layer that's built within the blockchain network, which basically hashes every single transaction. So what happens is whenever I send 5 Bitcoins to my friend Bob in Australia, when I enter that the transaction, the second I hit submit, that transaction details of my, let's say, 5 Bitcoin units and my wallet address, the result of it gets hashed and transferred over into the blockchain network, right? Again, the reason is security, to prevent malicious actors and attackers from being able to intercept the communication and finding out what was being sent from which sender and to which receiver. That's the most important point here, because at runtime, when the transaction actually happens, it can be vulnerable for attacks. And this is why blockchain uses advanced level of hashing to be able to encrypt the communication between the sender and the receiver, right? So let's go back to the slide here. Okay, so SHA 256, it's a hashing algorithm, and you can just open this link here. I placed a link into the document of the course. You can open it up and just simply play around with it and see how it works, and just understand the main concept about hashing and how this works, because it's imperative, because we're going to be seeing this in detail in the next few lessons and the next sections, and it's going to be building up on top of this. So make sure you have a deep understanding of what this means, right? In the next lesson, I'm going to show a video of how blockchain is being used in real estate. All right, so I'm going to stop right here, guys, and I'll see you guys in the next lesson.